Good afternoon, everybody. We are here to discuss on how we are going to solve problem 14.4. This is related to the previous reporter, which is Vince's group. And this is, if you are still remembered, they've discussed the work of force and principle of work and kinetic energy. Our problem has something to do with their problem, actually, with our topic, work energy and impulse momentum principle for a particle. So let me give you just a recap, guys. If we're going to talk about work, this is the energy transfer from one object to another. Let's say transfer a mechanical energy from one object to another. So when we say mechanical energy, this is the sum up of kinetic and potential energy. And we already aware that kinetic energy is in motion, and then the potential energy is at rest. So now also the impulse momentum method, this is best suited for determining the change in velocity along the time travel. So here, this is our problem. Let me read it for you guys. 1 kilogram collar that slides along the frictionless vertical rod under the actions of gravity and an ideal spring. The spring has a stiffness of 160 Newton per meter and its free length is 0.9 meters. The collar is released from rest in position 1. Use the principle of conservation of mechanical energy to determine the speed of the collar in position 2. So this is the diagram. So what we have here, we do have the collar that is connected to the spring, and we also have the vertical rod. But let's not dive into this problem or to dive into our solution. We need to determine, or we need to get some information what is principle of conservation of mechanical energy, because what is required in the problem is we need to determine the speed of the collar in position 2. So Mr. Abraham will going to discuss the conservation of mechanical energy.
So conservation of mechanical energy. Conservation of mechanical energy is composed of two energies, the potential energy and the kinetic energy. The potential energy has two involved energies which are the elastic potential energy and the gravitational potential energy. So particle, body, and closed system of bodies. Particle is the color that is in the problem. Body is the spring color relationship of the problem. Closed system of bodies is the particle and the body itself. So combine si particle ug si body kung mupunta sa closed system of bodies. So kani silang tulo conservative sila, meaning wala external force nga ma-involve while mabuhat ni siya mga energy. So next slide. So sa conservation of mechanical energy, sa katong problem na to, natay duha ka mechanical energy, which is from the position 1 and the position 2. So sa position 1, there is a formula of V1 plus T1, and which is equals to V2 plus T2. So sa position 2 na. Sa position 2 na. So ang purpose ng equals kay if one part sa equation kay musaka, dapat musaka po ang biggest equation. So meaning directly proportional sila. So the general formula behind the mechanical energy is E is equals to T plus V, which ako nang giniliha nga. T is denoted by the denotation of kinetic energy, and the V is the potential energy. So well, siya, E1 plus E2, or the change of mechanical energy. So, next part.
Formulas for potential energy. First is the constant force. Potential energy of a constant force, Vf, is equal to negative Fd, where F is the magnitude of the force and D is measured from the reference point. Number 2 is the weight. Potential energy of a weight, or also called as gravitational potential energy, Vg, is equal to WH, where W is the constant weight and H is the height.
Okay, so we have here the third formula of potential energy, or the spring. So as what we can see here in the image, we have here a deformed length of the spring where elongation is measured from its free length. So, ano yung elongation niya. So, to calculate, makuha na ito yung elongation or range sa free length to here, okay, we are going to use the elastic potential formula, or the V of A is equal to 1/2 K, or stiffness sa spring, times the elongation squared. So, lastly, we have here the fourth formula of potential energy, or the gravity, where MA and NB are attracted towards each other. So we see here that gravitational potential energy of the system consisting of MA and MB, we are going to have this formula, the V of G is equal to negative G MA times MB over R. So, as what we can see here, negative Fermi ang gravitational potential energy, since object man is going downwards, so man ang gravity ng negative. So ang R kay pa-infinity po ni siya, kay ang duha ka distance magkataas man. So since samtang magkataas ang distance sa two bodies, kay the longer the distance, kay magka-positive man o malas sa negative.
We are going to discuss now the solution to our problem. So we have it here. This is our problem again. And then if we are going to determine, first thing that we need to do is to write out the givens. So what are the givens? So we are giving constant stiffness of 160 Newton per meter. So this one. We also have the non-stretch length of 0.9 meter. And we also have the 1 kilogram of collar at rest, position 1, which is at collar nato is at position 1. Here, this is the collar that is connected to this spring, and this is at position 1, and this is the position 2. If you're going to notice or analyze this diagram, you will see there that the motion is in upward. So this one is in upward. And now let's begin. Let's solve this problem by getting the gravitational potential. That is the first thing that we need to do here. But before that, if we are going to look and check sa result ato, if going upward position 1 from position 1 to position 2, mo na siyang result. And if you are wondering why diri ra siya photo, because diri ra jud ay ang limit. So next, these are the formulas that they have discussed with Mr. Chua and Mr. Ompad. So the T1 plus B1 equals T2 plus B2. This is the conservation of energy. We just basically use this conservation of energy. But how we are going to find this conservation of energy? Simple. We need to get the gravitational potential and also the elastic potential. This is the formula of our gravitational potential, and this is our formula for the elastic potential. So first thing that we need to find or calculate is the gravitational potential. So let's begin first with position 2. So as you can see, gravitational, this is the weight times the distance y. So the distance y is respected to over the 2. It's like, it's kinda, diri na to this at pangatawang ground. Moni atong dato, moni atong ground. And then, this is for, since this is our datum, so which means our position 2 is 0.8 meters away from our position 1. So this is 0.8 meter multiplied by 1 kilogram, which is our mass, and then 9.80 or 81 as our gravitational acceleration. So the result is 7.84 joules or Newton per meter. So since we already have the result for position 2, we need to divert our attention to position 1. So since we all knew that our datum is at rest, which is our position 1 is 0. So we already done with our gravitational potential, so we need to find our elastic potential.
So for the continuation of the solution, to find the elastic potential energy, we have this formula. But before that, we get through this formula. Ato sa pangitaan ng ilang equation. Since sa problem, there are two position 1 and Since ito ang problem, there are two positions, the position 1 and position 2. Therefore, there are two elongations. So, sa duha ka elongation, there are different formulas. For elongation 1, ito we gamit is the square root of the height squared plus the length squared minus the free length. Since ang ato ang height diri is 0.89, then ang ato ang length is 1 meter. So, ato siyang i-substitute sa formula. Our height is 0.8 squared plus the length 1 meter squared minus the sa free length, which is given sa problem na 0.9 meter. So, our first elongation will be 0.38 meters. Then, for our second elongation, we have this formula, length minus the free length. So again, ang atong length is 1 meter minus 2, the free length 0.9, then we got our elongation 2 will be 0.1 meter. So now, since nakuha naman na itong elongation, the first and second elongation, ato sila i-substitute sa formula of the elastic potential energy. So, unsa na yung formula sa elastic potential energy? So we have the elastic potential energy is equal to 1/2 times the K. Ang kanit K, muna siya ang stiffness sa spring. So muna siya dali. Muna dali ang K or the stiffness. Then multiplied to the elongation squared. So since namatay daw ang elongation, therefore duha pa na ito ang elastic potential energy. So for our first elastic potential energy, ato i-substitute ang kanang mga values. So we have 1/2 times the stiffness, which is 160 Newton per meter, and then multiply to the first elongation, which is 0.38 meter squared. So our first elastic potential energy is 11.55 Newton meter. And for our second elastic potential energy, same process atong first. Again, ang stiffness 160, then multiply to the second elongation 0.1 squared is equal to 0.8 Newton meter. So now, nakuha naman natin ang elastic potential energy. Let's move on to the kinetic energy. So the formula of kinetic energy is T. So T, na-study siya as the kinetic energy. So T is equal to 1/2 times the mass or the weight of the the weight of the polar V squared. Since sa long problem, ang position 1 is at rest man. I-mention man dito na ang position 1 is at rest. So therefore, wala siya movement. So 0 ang iyong kinetic. Whereas ang T2 or the kinetic in position 2 kay movement siya. Therefore, ato siyang gamiton, i-substitute na to ang formula based sa given. Since ang ato ang the mass or the weight of the polar, as what mentioned sa problem, is 1 kilogram. So 1/2 times 1 kilogram and times the unknown, which is the speed. So mo man itong ipangita sa problem. So we get 0.5 v sub 2 squared. And now for our last solution, so we have the conservation energy. So the formula for conservation energy is V1 plus T1 is equal to V2 plus T2. So one is siya ang general formula for conservation energy. But in equating the initial and final energy, so we derived the formula as the T1 plus the gravitational potential energy plus the first elastic potential energy is equal to T2 plus the second gravitational potential energy plus the second elastic potential energy. So, na naman tayo mga values. Again, ang T1 na to is constant, at rest, 0. Then, ato ang VG1, 0 gapon. And ato ang VE1, or the elastic potential energy, is 11.55. Then ang ato ang T2 is kaning 0.5 V squared. And our VG2 is 7.84. Ano siya ang result. Then our VE2, the elastic potential energy, is 0.8. So kung ato na siyang i-sheet solve, gamit na itong calculator, makuha na siya ang answer. So the speed of the polar in position 2 will be 2.41. So from here, position 1 to position 2, ang iyang speed sa iyang pag-upward will be 2.41 meters per second. So that will be all for our report.